Welcome to session 6AK on the Z performance and capacity stream. Today we have Martin Packer and Scott Ballantyne with a session entitled What's the Use? And this is all about usage data. I know many companies collect usage data for SCRT reports for IBM, but there's many more uses than that. Whether it's SMF89 or SMF30. So that's what it's all about. Please do remember to fill in your feedback at the end of the session, and it's session 6AK. So if you need that to fill in the form, that would be useful. Also, please remember to support our two charities for GSC conference this year, and that's the RNLI and Guide Dogs for the Blind. Details are on the website. I don't think there's much else. We're at 15:32. So I think without further ado, I'll pass over. But before I do, just remember, if you've got any questions, just put it into the chat on the Zoom session and we'll try and cover them at the end. I'm sure Martin and Scott will be only too pleased to answer any questions you might have. So without further ado, Martin and Scott, over to you guys.
All right. Thank you, Colin. So yeah, on the questions point, if you don't have any questions, we'll actually answer the questions that were asked the last time we did this presentation because they were of interest. so it's in your hands very much. So anyway, most people I think know me. I'm Martin Packer. I'm what the hell am I now? Troublemaker, troubleshooter in the field for IBM on the mainframe. Been doing it for many years. And Scott, why don't you introduce yourself before I plow on?
Sure. So I'm Scott Ballantyne. I'm a developer in well, all three of what we internally call the job management components, the SMF as well as the job scheduler and device allocation processing. So I'm also a bit of a troublemaker and certainly enjoy working with Martin on putting this presentation together too.
Yeah, so this presentation actually came out of a conversation on our internal Slack channel a few months ago. I can't even remember how the conversation went, but I think I basically said to Scott, "Hey, look, there might be something in this IFA usage macro and usage data thing that's worth sharing with people." And in fact, some of the audience I know have been I've had conversations with about usage data in the past. Including Stephen, just to let him off, Stephen Hall, just let him off gently. We had conversations which led to him talking to Barry Merrill about MXG support for it. So yeah, it's unfair to say to Scott, next slide, please, because he won't get the cultural reference possibly that the Brits will all get. So, but anyway, next slide, please. Right. So yes. So as Colin said, look. You're probably collecting SCRT data or SMF89 subtypes 1 and 2 usage data anyway, because they feed into SCRT for billing purposes, whether for IBM, I'm going to say and/or, but mostly other vendors. But usage data has got many more uses than that. And really what we're going to do with this is we're going to make this face in two directions. So unlike the way around it is in the abstract, so Scott's going to talk about the vendor perspective really and how to use the IFA usage macro. Now, possibly nobody on this call is actually a developer, but as customers, if you talk nicely to your vendors and open their eyes as to what they could do to help you, maybe they will take IFA usage as a macro and usage data seriously in ways that will help you. And I think, you know, delighted customers turn into loyal customers, et cetera, et cetera. So there is something in here for vendors, in fact, a lot in here for vendors as well. So we're going to do this in two parts, basically. So Scott's going to talk about the IFA usage service or macro, whatever you want to call it. And then I'm going to talk about some things you can do with SMF89, a little bit of SMF30, mostly 89 subtype 1. Based on the assumption that a vendor makes a reasonable fist of using it, whether they do today or whether you as a customer goad them into doing it in the future. So without more ado, I think I'm handing over to Scott.
Sure. So, and just to kind of add to that, one of the reasons, even though the part I'm going to be talking about is probably more tailored to vendors, even if you're not somebody who's going to ever code this macro, having some understanding of how it works, how it behaves, you can kind of get some insights into what the program is doing, even if you never actually code this thing. So that's why we wanted to talk about it. So, all right, I think we've just covered the introduction. I'm gonna talk about the macro, then I'm gonna hand it back to Martin. He's gonna talk about the SMF records themselves and how you might be able to use the data. We'll have we'll wrap up at that point. And then we now actually do have an appendix here, which we're not going to go through, but it's got some coded samples for what the invocations actually look like, if you're interested. So I think we've talked a little bit about this already. Why do you care about usage data? From the IBM side, there's obviously the SCRT aspects of this, right? You might want to actually license your customers using usage data. So, knowing what services here are important, but also, you can wow your customers with this if you're a vendor by giving your customers useful usage data and hopefully doing it cheaply. So, and then on the customer side, generating usage data that feeds into the SCRT reports, it's great to just run the SCRT reports, but maybe you want to know a little bit about how the data is generated, what's actually going into SCRT. But then, there's additional value. I think that's where when we come back to Martin's side of this presentation, knowing what's in the type 30 records, what's in the type 89 records, you can get some insights here. So we have a simple timeline, and Martin, keep me honest on this. This is just sort of give you a little bit of perspective of what an application or what a job might be doing. So, going from left to right is, time, and you can see the job is running here from left to right. That's the top row in blue. We have a two-step job here. The first step is using IFA usage. The second one is not. And so the step that's using IFA usage might invoke it a few times in here, and we're going to talk about what it's doing when it invokes these things, and moving your way down here, just pictorially where the various SMF type 30s as well as the 89 subtype 1s get issued. We have several intervals. This job runs over a few SMF intervals. So you can see where we issue the interval records. Those are the subtype 2s. As well as the 3s for the last interval in the step. The type subtype 4s are the step end, and you'll have 2 of those, as well as the subtype 5s as well. And then again, you can see where the 89 subtype 1s get issued. At least for this job, the 89 subtype 1s have, they collect up all of the products running in the system. So, even though we don't show it on the picture here, there might be 89 subtype 1s also happening that occur for other jobs, but this job won't be included in it, or we're only showing where this job is included in the 89 subtype 1s. Martin, is there anything else you want to add to this one?
Yeah, a very, very minor point. The dark orange arrows are incomplete intervals. Is the only thing I would add to this picture. And yeah, there's a typo in the top. It's timeline for a 2-step job. I wrote single step. Shame on me.
All right, we'll remember to fix that.
Before anybody's going, hang on a moment, I don't understand this.
Okay, so let's talk about the macro itself. First, let's define what a product is, right? There are 5 items that make up a registered product. Actually, there's a little more than that, but the main 5 items. When a product registers, it gives us the product owner, the product name. Those are both 16-character fields. Then something called the product version, the qualifier, and the identifier. Those are each 8-byte fields. And we combine these all together to make up a unique product. That's from the SMF side. Now, SCRT is going to be a little different in the rules that they use. We're going to get to that a little later in the presentation. One other thing that we also keep track of is if you're an authorized user versus an unauthorized program. We're going to track those differently, and we'll come back to why and how that happens again a little later. So first, we're going to show you the IBM definitions of what these fields are, and then Martin and I have some recommendations. Hopefully the product owner is pretty obvious. IBM products, we state that we should use IBM Corp in the product owner field. But yeah, hopefully that one's obvious. Likewise, the product name hopefully is obvious as well. For example, most of the ZOS, core component stuff uses Z/OS. There's a few options for the product qualifier. This could be a major subfunction of the product. So as one example, for TSO, we use TSO/E. But you could also, this could also be used to differentiate between multiple instances of our product if the product can have multiple instances running. For example, a subsystem might use the subsystem name if there can be that they can have multiple subsystems for that product. We might use that here. Product version is going to be, again, hopefully obvious, the version information for the product. For ZOS, we use the, something like 02.04.00 for ZOS 2.4. And then the product ID, we're going to use our product order numbers. That would be something like 5650-ZOS. All right, that was the documented IBM, what these things are. Here are our recommendations. Product owner and product name hopefully are pretty obvious, right? You're going to be that's going to be the name of the company that provided the product and the name of the product. If you can have multiple instances of the same product, we'd really suggest you keep them having the same product name. There's other ways to differentiate later on. The product qualifier, there's a few different possibilities. This depends on the product, of course. For if there are multiple instances of the same product, each one could have some identifying information such as the subsystem name. If there's only one instance of the product running, but it maybe has multiple subfunctions, that could be used to differentiate the subfunctions. And none of the above, you actually don't need to specify a qualifier. This field's optional, but there might be a wasted opportunity here. So we'd suggest, be creative. Product version is another optional field. We really recommend it. Use whatever format is appropriate for the product. Our suggestion would be the vv.rr.mm format. But again, use what makes sense for the product. If something else makes sense, use that. And generally, all products from a single company should strive for consistency where possible. And I think Martin's also going to talk about consistency later on.
Certainly am.
Yes, he is. And then finally, product ID. That's another optional field. Again, we'd recommend, putting something in there. And we told you how IBM products use it. So again, all these fields can be reported on. So consistency, both on the content side and the formatting side. Again, Martin's going to go into that a little more too. That's important. So on to using the macro. There's several different functions. There's actually 6 of them. We're going to talk about each of them individually. So I'm just going to go ahead into the first one, which is something called register a product. To identify the product to SMF, the product issues this IFA usage macro with the request equals register option. And this is the first service that has to be done there. After it, you can do some of the other IFA usage services, but you have to do this one first. There's one exception, status, and when we get to that one, you'll understand why that could be done first if you want. There's 3 types of registrations. And again, we're going to talk about each of these. So let's go ahead. The first one is domain equals addr SP or address space registration. Why would a product use this? This is an probably going to be an application that wants to track all of the work in the address space. So that's why they'd register this way. This would probably make sense for something that's running as a started task or maybe a batch job. So the application flow, the address space starts, it invokes this IFA usage request equals register service, does some processing, and then it, in its termination processing, it's going to invoke this IFA usage request equals deregister service, which we haven't talked about yet, but we'll get to soon. Domain task scope equals all. This is the second type of registration. It's similar to address space. An application that runs as a task under another address space would register as domain equals task scope equals all. This would probably make sense for a product that executes in another address space and gets attached as a subtask in that other address space. That's probably the most likely case. And so the typical application flow here is the address space starts and it attaches a task to run this other product. The task is going to start, and it's going to the product's going to invoke IFA usage request equals register, do some processing, and as part of the task at the end as the product is exiting, invoke IFA usage request equals deregister, probably right before the task gets detached, and then the address space ends. The third one is a bit different. This is domain equals task scope equals function. And an application that is called by another application would usually use this one. Now, as opposed to the one we just talked about, which is probably an attached program, this would make sense if your product is executing in another address space and it's invoked by a link or a branch or a PC where it's actually called, it does some processing and gives control back. For these domain equals task scope equals function registrations, there's some other IFA usage request types that the product has access to. But first, let's talk about what a function might be. So here's an application example. Let's say you have a product that can retrieve data from some repository. It has a connect service that allows the user program to start some processing. It has a get data service to retrieve some data, and then it has a disconnect service to stop reading data. You can think of a paradigm like, opening a data set, reading records from it, and then closing a data set. Similar with something like system logger to read from a log stream. So the application flow. The user program invokes this connect service. Under the covers, that's going to invoke IFA usage request equals register. Then the user program does some processing, and then it says, all right, I'm ready to go get some data, go invoke the get data service. It invokes IFA usage request function equals begin, which we haven't talked about yet, but we're coming up on that soon. It does some processing and then invokes IFA usage request equals function end and returns back to the caller. And then it does some other processing in the user program. Then it calls this disconnect service, at which point the product's going to invoke IFA usage request equals deregister. So that's kind of the flow of what this application might look like. So let's get into what these services are that I just talked about. Function begin. So this has to be done after the product registers. Once the product is registered and it's ready to start accumulating CPU time, it would make this function begin request. So just to point out, you have to do that prior request equals register. It has to be under the same task. And it's probably not, I've probably hinted around about it, but here's the point where I'll say, unlike the address space and the task registration, our task scope equals all registrations, doing a registration for a scope equals function request does not automatically cause CPU time to start getting tracked. You actually have to do the function begin to start tracking that. And that's because this is part of the task it's running under. It's not the complete task data that we want to capture. So function begin says, all right, I'm now executing under the product. Let's go track some data. The second service is something called function data, request equals function data. Again, it has to be done for a registered product, and this would be done in between or after the function begin call. This is not all products are going to use this, but this allows the product to track its own data if it wants to. One example is if the product, let's say it tracks some number or it processes transactions. Maybe the product wants to track the number of transactions it processed in addition to CPU time, right? Again, it's optional. You can do multiple of these calls. Data gets accumulated, not replaced. So that means if you call us with, say, track value 1, call us again, track value 2, we're going to go 1 + 2 = 3 and store that away. So it doesn't replace the value, it accumulates, it adds to it. The data we can store, you have one 8-byte field. It can be one of the following formats: CPU time, which is store clock format, binary format, which is an integer, and then floating point format, which is a long floating point hexadecimal value. The product has to pick one of these. You can't, the product can't store in all 3 of them. And obviously, the reason why you have to pick one, we've got one 8-byte data field, and I don't know how to add a store clock format to a binary integer in any meaningful way. So that's the reason why the product has to choose.
I was just going to make a very brief comment that obviously these are numeric values, right? I mean, the notion of accumulating character strings, for example, is a no-no with this. So yeah,
correct.
Yeah,
very, very good point. So yes, it really has to be numbers. Again, we're accumulating things, so not replacing them. So the product has done a function done a register, function begin, maybe some number of function data's calls. Then it wants to exit the function. At this point, the function's completed. It should make this request equals function end request before returning to the caller of the function. The product will no longer accumulate task time at this point once the function end call has been done. However, there's nothing preventing the product from doing a subsequent function begin call to start accumulating data again. So going back to that example on the previous slide, we had only shown one of those get data services, but the application could have invoked get data a dozen times or 100 times to gather data, and each one it would do a function begin, function end, function begin, function end, and just the data that's or the time that's accumulating in between the function begins and function ends gets accumulated. All right. Deregistration. It doesn't matter which type of registration the product did. Whenever the product is done accumulating data, the product can deregister the product either explicitly, or there's cases where we'll do it implicitly. And this says, I no longer want to be considered a product anymore. So we're no longer going to accumulate usage data. Note that the deregistration only affects the current scope, whether it's address space, task, or function. It doesn't affect other address spaces. They're going to continue to accumulate data. So as an example, if you have 3 CICS regions that are registered, if one of them does a deregister, the other 2 are still accumulating data. There's, we're not completely disabling the product across all the address spaces, just this one. So I hinted at these, there's 2 types of deregistrations. The first one, explicit deregistration. The product can explicitly deregister by invoking the IFA usage service. It doesn't matter how the product registered, again, whether it was address space or task or function scope. It's just do IFA usage request equals deregister. We really recommend that the product do this whenever possible. But there's also something called implicit deregistration, where the system is going to deregister the product on the product's behalf. When the job or address space ends, any products that were registered by that job or address space are going to be deregistered. Likewise, if a task ends, any products that were registered as domain equals task by that task, whether it's scope all or scope function, we're going to go deregister that for you, deregister those products for you as well.
So presumably then the key cases of those are going to be things like a bends or somebody cancelling the address space. We're going to have to do the deregister implicitly.
Exactly. If we're going to clean up if something goes wrong under the address space or task, we'll catch that. We obviously do not want to leave products registered hanging around after the product is ended. So then the last service, this is this IFA usage request equals status function. And this is the one that the product can use at any point, whether it's registered or not. This is that unique exception. And really all it is, it can be used to determine if usage data collection is active. So to put it in other words, is SMF recording the type 89 records? An application might do this before registering just to determine if there's value to registering. The application doesn't have to, but it could. And return codes are either 0, which means the usage data collection is active, and therefore there's actually value to registering. Or if return code 4, which means usage data collection is not active, that means there's really no value, no matter how much the product calls IFA usage. We're just going to keep giving back. We can't do your request return codes. Again, optional service, and that's really all it does is tell you if SMF is recording type 89s. Okay, so we talked about the macro, all the services it has. Who can code it? Well, anybody. IBM products, non-IBM products. If you have your own applications, you can use this. These are all documented programming interfaces. They're in the SMF book. You can go look at the details there. All right, that's who. How about why? For many products, they just want the data to be available for billing purposes, and that's a good reason by itself, but it's not the only reason. You can actually get a lot of information about your applications. Martin's going to show some pretty good examples here and talk about that. But you can get some insight into your applications with this. You can get CPU time from other places like the SMF type 30 records. But the nice thing about the 89 subtype 1s, they accumulate the product time in one place. So if you have an application that starts and stops, it'll accumulate there. If you have multiple instances, we'll also accumulate those as well. And then for products registered as functions, the ability to track function data, along with CPU time is valuable. So that going back to the example of if it's a transaction, processing product, tracking the number of transactions might be valuable. I talked a little bit about authorized versus unauthorized. IFA usage does do things a little bit differently. If you're supervisor state, you have access to everything I talked about, and it's basically unlimited. You can, if you're a supervisor state program, you can go ahead and register and do whatever you want, as many products as you want. By default, for problem state callers, we're going to default to unauth serve equals base, which is a function we put in a few years ago. You're limited to request equals status and request equals register. So you can't do the deregister, you can't do the function begin, function end, function data services. And we limit the number of unauthorized registrations. Quite simply, we don't want some user program going crazy registering products that show up in your SMF records. So hopefully the rationale for that is obvious. However, problem state callers, there is an option we added. I think it was ZOS 2.3, but it was fairly recent, where a problem state caller can tell us to check for access to a SAF resource to see if that user is allowed to register that product. If that if we have access to that resource, then the product is allowed to use any of the IFA usage functions. If we don't have access to the resource, we actually fail the registration. So, and then there is also a limit here. Again, we don't want things running away too much, but it's capped at 32 unauthorized registrations per domain and scope, which hopefully is more than anybody needs. 64-bit usage, I probably won't go into a lot of detail here, but there we do support both A-mode 64 and A-mode 31. There are some requirements around A-mode 64. They have to do with the size of the parameter list. They have to do with the keywords. We actually have different keywords or separate keywords for A-mode 64 and A-mode 31 callers. The important thing is you have to match the keyword to which A mode you're in. So if anybody is coding this, I'll say, check the fine print. I'm not going to spend a lot more time on this because I don't think most of this audience is going to be coding the macro. So let's talk real quick about the flow of CPU time and how it's handled. Task time and SRB time, we accumulate those separately, but it's similar for both. In general, we gather the CPU time from the address space or the task. It depends on how it's registered, of course, right? For domain equals address space, we get the address space time. For domain task scope all, we get time from the task. And similar for domain task scope equals function, but we only accumulate the time in between the function begin and function end calls. The data for the product and each address space that has registered the product, we store that in SMF control blocks. They're not stored as part of the data is in the address space, but for the SMF type 89 records, we store the data outside the address space. That means if the product deregisters and the address space or task terminates, we still have that data that we can report on, at least up through the next interval, right? So we can continue to report even after the product has ended. And so the data flows from that registered domain, again, whether it's the address space or the task, into a area that represents the product in that domain. Again, it doesn't matter what the domain is, whether it's address space or task, and it hangs around like I mentioned before. From that area, we're going to put data into the type 30 records to track the usage of that product under the address space. So the type 30 does have a usage data section just for the product in that address space. But we also aggregate that into the SMF type 89 subtype 1s, which track all of the registered products on the system. I think most times if somebody's looking at product data, they're probably looking at the 89 records rather than the type 30 records, but there's data in both. And so we had that pictorial view early on. This is a similar looking picture, but not exactly the same. Again, time is going from left to right on the top. We have the job at the top. This is a two-step job. Each step is doing an address space registration. So early on in the step, it does a register, then a deregister late in the step, and similarly for the second step. And you can see where the SMF records get issued. We've got 5 intervals here. You can see the various type 30 subtypes. Obviously, once the job ends, there's no more type 30s for that job. There obviously will be for other jobs. And then the 89 subtype 1s, while we have products registered, we keep issuing the 89 subtype 1s at each interval. And then after there's no more products registered, we won't issue the type 89s. Now, again, this is the type 89 subtype 1 will only contain this product. There might be other products registered in other address spaces. You'd still get a type 89 after this job ends, or type 89 subtype 1 after the job ends if there's other products that are happening. And then similar picture, if this is function begin, function end. So you can see where we have a couple of function begin, function end pairs. We don't show any function data calls here, but they could be in there. And you can see we won't have a type 89 record until we get a or we won't show this product in the type 89 record until we see a function begin, which is why that first interval won't have a type 89. And with that, I think we're into the SMF record information. So I'm going to turn things back over to Martin. So,
okay, thank you. And just to recap very briefly why we're talking about IFA usage macro at all, I think it's because let's assume we're all customers here, because that simplifies things. I think when you're talking to your vendors, you can have nice conversations with them about what they can do to help you, but you can only really have that conversation fluently, I would say, if you know how this whole shooting match works, which is why we've gone through the various things, which I won't list, right? So hopefully you're better informed than on any of my presentations on usage data to have that conversation if you feel the need. So beginning to get into customer land rather than developer land, I would say at this point in the presentation. So we surface the usage data in two places, really. We surface it in SMF 30 at the address space level and in SMF 89 at the LPAR level. So in SMF 30, the subtypes, just to recap, we have step start, which is very rarely of any use to anybody because that data is actually in interval subtype 2. Some of it's actually in after last interval, and guess what? It's in step end and job end, depending on what we're talking about. So I tend to concentrate on SMF subtypes 2 and 3 interval records, and I tend to concentrate for different reasons on step end and job end. And both those categories really are kind of useful in this story, actually. And obviously, this being address space level or job step level, the data accumulates in the address space for this. And it's surfaced in a section I'm going to talk about in a minute called the usage data section. Now, in previous conversations with you all, I've talked about usage data section, and that's the one we're going to concentrate on. And you can have multiple usage data sections, even for the same product, connected to by an address space. So, for example, it's very typical for a KICS region when connected to DB2 to have multiple DB2 usage data sections. Not just the one, likewise MQ. So in principle, I mean, when I first started processing this data, I rather naively grabbed the first one, which is all very well. You want all of them, actually. At the LPAR level, we've got SMF 89, which is, well, we've got two subtypes. We've got the usage data from what we've been talking about, which is IFA usage, and we've got state data, which is from IFA EDREG. Now, the IFA EDREG does not contain any CPU numbers, but the IFA usage stuff does. So that's one of the key differences. Really, hello, I was here is about all you're really getting out of the subtype 2. And frankly, they are different products I typically see in the data from what I see in the usage data section in the 89. Right, and the data for SMF 89, as Scott says, is accumulated outside of the address space, and it's by product, including down to the level of qualifier, as we will see in a minute. And that's kind of important. Seems like a niche, a nit, but it's actually kind of important in the story. And you get multiple sections in the 89 subtype 1, which includes extended analogs of the usage data section in the type 30. So this is actually SMF 30 because it illustrates some key points. So the first 5 fields, UPO all the way through to UPI, correspond directly to the product name, etc. 5 fields that Scott talked about. Right, so they come out directly. Nothing. I don't even think we do any kind of processing on them at all. Literally copy. And this sounds like a nit again, but you'll see why I'm saying that in a minute. Then below UPI, we start getting into numbers. So above UPI and including UPI is names, below it is numbers. So we have product TCB time. This is in hundredths of a second, by the way, and similarly SRB time in hundredths of a second. Then you have a field which is basically from the function data request data, 8 bytes, but it's, as we said, it's numeric. But you obviously want to know how to interpret that field. Well, that's what the UDF field is. It's a flag byte that you can parse to work out whether we've got, you know, CPU time in long floating point or a binary count or whatever we got here. Always a number, obviously. And then we have some flags. Well, we really have a flag about unauthorized registration, which if it's not set, I guess it's an authorized registration. So really, I think we think about the section as having two parts, two main parts. One is names and the other one is numbers. Okay, so we're going to get into what on earth are you supposed to do with this stuff now, or heading towards it, right? So the data flow through SCRT. Obviously, as a customer, you have to dump the SMF data to a data set, and then you run SCRT against the SMF data, and you create reports, and you send the reports to IBM. That's what the customer does. Now, SCRT, in a bit more detail, uses the Type 89 records, also 70 subtype 1, to determine if a product is active. Now, Scott, you probably want to explain this next point because I think it's yours.
Sure.
You want to take this slide?
Yeah. So it SCRT it uses the Type 89 subtype 1s as well as the subtype 2s, but in general, it's not going to use the directly use the CPU time accumulated by the product. Now, there's an asterisk next to that. There are certain cases, and I'll be honest, I'm not an SCRT expert. You know, we could probably have a whole hour on how SCRT does its processing, but there are a few exceptions. But for the most part, it is not going to use the CPU time accumulated by the product. Something else, and I'll also take this part of it. SCRT has its own product catalog. So for IBM products, you know, we talked about those 5 fields. SCRT doesn't use all of those. It only uses the product name and product ID from the SMF 89 record to identify the product. So it's going to accumulate all of those other fields, the qualifier, etc. It's gonna ignore those. For vendor products, the vendor can choose what they use, but product name and ID, that's what's recommended. So there's some options for vendor products. What this means is the product catalog is important from an SCRT point of view. If you just use IFA usage to generate usage data, SCRT is not going to report on your product. So you actually have to get your product registered in the product catalogs for SCRT in order to have that happen. So, and then Martin, I'll turn it back over to you to talk about the SMF 70s.
Right, now as I understand it, SMF 70 here really is used to tell SCRT the size of the LPAR in which the work is running at any given moment. So that's really where that comes in, where the CPU numbers come from that are used directly. Okay, so I'm actually now showing you some real reporting in the bottom third of this slide. And this, I need to keep this clear in my head for what I'm about to tell you. This is from SMF 89, not SMF 30. I'll tell you when we start looking at what SMF 30 can do, but bear in mind this is SMF 89, which is a very, very scalable data source. It's low volume records, it's up at the LPAR level. Everybody should have it on, no ifs, no buts. Probably you have to for the SCRT reason. Okay. Now, the first thing you can do with SMF 89 is you can summarize the versions and releases of the products that are in SMF 89. Actually, this is true of subtype 1 and subtype 2, but I'm really talking about subtype 1 here. So in the following, this is actually data from a real customer. I might even vaguely remember who it is. The only thing I've edited in this is the SMF ID, just to spare their blushes, not that they really have any. Okay. So the first thing you will notice, I hope, is the second column in the table. This is where some products, well, these are all IBM products, aren't they? You see, we don't even follow our own advice here, or Scott's advice here, right? So there is some inconsistency here, and this is a tale against ourselves, maybe not Scott and I, because it's not our fault. But you know, but if you don't want to look as foolish as IBM does, whoops, did I say that? As a vendor, you might actually want to have consistency between your versioning across all your products that get registered and show up in 89 this way, right? So this is part of what Scott was saying earlier about, hey, look, consistency and stuff really does show up verbatim. Okay. The identifier field, I think we're all right on, because look, this is pretty darn consistent, isn't it? The other thing to say is, while those versions are irregular but clearly parsable, you can take 2.3.0 and turn it into 2.3. You can do the same with all the others, right? Capitalization might be, consistency might be a good idea. And again, notice node.js for ZOS. That's not how I think we would like it to be capitalized, ideally, right? Now, the DB2, by the way, you can snigger about it, there not being a little b in DB2 here. This is exactly how the IBM coded it, whichever development team in the record, and it's exactly how it shows up here. So if you were a vendor, you probably want to be tidier than this example is. Okay, nonetheless, at the system level, you can see there's a difference between sys A and, let's say, sys B. Actually, let me just get rid of this window. Right. And indeed a little bit between sys B and sys C. So you might say, well, I've only got 2 LPARs. This is a no-brainer for me to keep track of this stuff. I think you all know by now, I don't really subscribe to that view. And if you're a customer with dozens of LPARs, and I know some of you on this call actually are, it's a jolly good idea to know, for example, we still have DB2 version 11 on all 3 of these LPARs. You know, the journey to version 12 is not complete, it's only on sys A. It might be handy to know somebody seems to be playing with Node.js on sys A, but not on the others. Yeah, that sort of thing can be handy. So you can do a very easy, highly performant query on where are we running which version of any of these products. And these are obviously genuine products. So yeah. Now, I'm deliberately not showing you what vendor data looks like. One major vendor we all know and have a complicated relationship with historically has asterisks in their version field, or at least they did for a very, very long time. So you know, I'm not going to expose them to ridicule, apart from to say some people don't get it right. I've shown you some ways we don't get it right. The other thing is, actually, Scott doesn't know this. I've just had a conversation about Liberty because it shows 00.00.00 as its version. And I just had a conversation with Dave Follis about trying to get a decent version in there for Liberty, because, to be honest, Liberty doesn't necessarily follow the Kix release. I mean, you could say, well, Liberty, well, 5.4, the release of Liberty must be somewhere in a range, but I would think we could do better than that. The other thing I would say is, in this, you don't get the function level in DB2 either. But you know, so there are a few minor bear traps in all this. Okay, so that was up at the LPAR level. Now, still with SMF89, you can do more. And this is a thoroughly scalable way of carrying on, I would say, again, because it's SMF89. The product qualifier field that Scott talked about actually, for some products, yields a subsystem name, a useful subsystem name. So for DB2, the subsystem name is the product qualifier. Yes, obviously you've got blanks on the end, but that's it. With a little messaging, with a little massaging, I've obviously never had one. I need one now, don't I? With MQ, you can actually, again, pick up what the queue manager name is. So for example, if you're confronted with an MQ product qualifier of MQP IMS, you can read that as the IMS connection or an IMS connection to subsystem WMQP. Not really difficult, I would say. One thing I would say is IMS says, hello, I'm IMS, but it doesn't actually encode the subsystem. It does encode the version quite reasonably. So the point about this slide is, without going anywhere near SMF30, which is where you may think you have to go to pick up subsystems for DB2 and MQ, you get it in the 89 subtype 1 with a little bit of work, but not much. Now, this is the bit where I say, if you are a vendor and you have the concept of a subsystem or something like it, this would be a golden opportunity to fill in the product qualifier with something useful. And when Scott earlier said, look, wasted opportunity if you don't fill anything in, this is what we're thinking of. You could put in usefully something like a subsystem name, or alternately a product function if you want to highlight the presence of a particular product function. So this is one layer down from what I showed you just now, but it's with SMF89 still. Okay, now this is where it gets a little bit tricky. We're coming down to SMF30 now. You could, if you have a lot, let's say, of DB2 subsystems, you could begin to understand the role of a DB2 subsystem by tallying the connector's CPU. You would typically use SMF30 interval records to do this. Now, one thing to note before we go any further is, by default, DB2 has an option SMF89 equals no. By the way, it's not even on the panels you use for tailoring the DB2 subsystem. Now, what that says is you don't get any SMF30 usage data, any SMF30 CPU in the usage data section. But you can still do some useful work in terms of understanding the nature of the subsystem. So you could tally the users, kicks, regions, batch jobs, whatever's own CPU from SMF30, and use the usage data section that points to a specific DB2 to say, maybe this, for example, if it's heavily dominated by kicks regions, the idea for this subsystem is it supports kicks in the day, probably batch overnight. So what I've done on the right-hand side here is I've done exactly that. I've taken the connectors to the various subsystems, and I've tallied their CPU, fully acknowledging that not all that CPU is going to be in DB2, but it gives you some idea. So we've got a bunch of subsystems here which are predominantly kicks, at least in the day, but they also do a few other things. A little bit of DDF in some of them, in the right-hand 4 that show significant CPU, but not in the left-hand 2. And at the top is a bit of other, which is probably, I don't know, IMS or RS or something that we haven't tallied here. So it gives you a bit of an idea of what a subsystem is for, not necessarily terribly deeply architectural, but at least it gives you some clue. Now, for MQ, you get this CPU directly in the usage data section. A couple of points here. SMF89 has not only TCB and SRB time, but it has zip time in it. So I suppose that could be used to gauge something else about the subsystem, let's say for DB2, if we got no 89 turned off. The SMF30 usage data doesn't include zip, but obviously the SMF30 record itself in other places has a lot of zip stuff. The other point I think I'll make here is CPU is actually a crude metric of a connector's importance. It is anyway, but in particular for MQ, the role of the CHIN address space is going to be underrepresented, because the CHIN address space, every time there's a message on the queue, the CHIN address space doesn't do much processing, whereas let's say a kicks region connecting to the queue via MQ is going to do rather more with it. So be careful about this whole business about the role of the subsystem. But I still think there's useful work that can be done here. Okay, now this is something I presented on before. Let's take the example of KICS regions, which is really what this slide and the next one, when we get there, will be about. What I have done is I have used the usage data section for all the KICS regions and pulled out the DB2 subsystem name. Let me just repeat that. I've taken the DB2 usage data sections from the KICS address space type 30, used the product qualifier to relate it to the DB2 subsystem. So we've got topology here, as I like to put it. The color coding is actually by, I think, the port class, and we've got some other numbers that are nothing to do with the usage data section at all. But still, the point I'm making here is you can extract, certainly for KICS, the topology of which DB2 subsystems, because they only connect to one, each KICS region connects to. Kind of useful topology, I would think. Particularly have a lot of KICS regions and maybe a lot of DB2s. Okay, now I'm gonna hijack this slide to say something else, but basically this is the same thing, same customer actually, but MQ queue managers. So you can use, just to repeat, you can use the MQ usage data section for the KICS region type 30 to get the queue managers that the KICS regions connect to. Now the point I'm going to make here, because I'm not sure we have it on another slide, is this. This is true not just for KICS, it's true, for example, for IMS. It's actually true for MQ using DB2 for shared message queues, and maybe less exotically, it's true for batch jobs. So I can tell, for example, if a batch job connects, job step even connects to DB2 and which DB2 subsystem it is. Slightly more exotic than that is the case of a supposed batch job that connects to MQ. Typically, those are long-running jobs hiding as pretending to be jobs, but really they're subsystems, but not in the strict subsystem definition of the term. So you can get some classification for batch as well as you can for KICS in terms of what it connects to and what it's for. Okay, so on the batch point, and I've kind of covered the first, let's deal with the right-hand side first. So we had a customer case with a service class that contained batch jobs that ran for a week. We didn't have interval records for these jobs, but we knew they ran for a week because you had step end ones. And we had a 15-minute gap noticed between the stopping of a batch job and it restarting again. Obviously a different job, but the same job name. The usage data sections pointed to MQ. And if you took batch C off the product qualifier, it said which queue manager they connected to. So the conclusion here, as I've just said, was these are message-driven so-called jobs, which is not an uncommon architecture. Now, one of the points here is if you're going to try and tune for these or against these, it's best to treat them in WLM as if they were a kind of started task. They aren't, but they are kind of a started task. So probably for those, a velocity goal would be appropriate, not a typical batch jobs response time goal. Again, you might treat standard batch jobs with velocity goals, that's fine, but with these, you certainly wouldn't want to use response time goals. Okay, right, so on the left-hand side is something I haven't come to, but it's kind of similar. So another customer had a WLM service class for DB2 utilities jobs. They had 4 LPARs and a sysplex, and across those 4 LPARs, there were 2 data sharing groups. One of data sharing, and each data sharing group had members on all 4 LPARs. One of those data sharing groups really was biased very heavily to 2 LPARs and the other towards the other 2. The program name for each step of each job in one service class is DSN-util-B, which itself suggests DB2 utility. Usage data section for those steps actually does say DB2. And the product qualifier said which DB2 subsystem it was for. So basically, you could see which jobs serviced which subsystem and therefore which of the two data sharing groups. So that was quite a nice case to have a dialogue with a customer about utilities with.
So I see we're running pretty short on time, so I think we'll let's go ahead and wrap it up. We talked about the timeline summary before. I mean, hopefully we gave you, without going through this whole slide, hopefully we gave you some good insight as to whether vendors, what value they can get out of this. Likewise, hopefully Martin gave you some idea of what you can do as a customer just reading the data. Not that I want to cut this off at the end, but Martin, is there anything you want to add here in wrapping up?
Not really. I mean, I just repeat that the whole idea here is, as we're probably mostly customers on the call, conversations with your vendors. If you say, well, actually, you could, with very little effort, help me out with, I don't know, architecture, taxonomy, whatever it is. That conversation, as I say, will go better. Now you understand what the source of this data is and some of the foibles. But equally, hopefully, you'll find some of the queries that I've demonstrated to be of value in their own right. Okay, there's one question.
Noticing DB2 version is as 12.01.00. Do you know how CDM levels would show show such as function level M509, or is that not included in SMF 89?
That's not in 89. I really wish it was. There's a slight problem with jamming it into the release and version and modification level, so they obviously won't do that. Place I go for that now is actually in DB2 stats trace, which is not so scalable, but not bad. It's not like a counting trace. So no, unfortunately, usage data section stuff doesn't say the function level of DB2 within 12.
Okay, I guess let's wrap it up. Sorry about running over time. We'll have to practice that. Martin and I will work on that.
We have to resist the temptation to stuff more information in.
Yes.
Right. Thanks very much, Martin and Scott. That was packed full of information, so that was really good. I've written loads of notes. I hope everybody else has. Thanks so much for the information. Please, everybody, do feedback on the session. It's session 6AK, but if you use your agenda set up, then you can just tick it and go straight in using the link on this session. I think we're more or less at the end of the day for technical sessions. I will just tell you about the GSC conference charities, which are the Lifeboat and Guide Dogs for the Blind. So please follow the links there and contribute if you can. It's a very worthy causes. Yeah, so that's kind of the end for the main technical sessions today, but we do have a keynote session around infrastructure and application modernization on IBM Z with Red Hat OpenShift. And that's Marcel Mitron giving that session. And that starts at 5. If anybody wants to hang on for that, that could be a very interesting session. So, unless there's any more last minute questions, I think we can probably finish there. And thanks very much to Scott and Martin.
Thank you, everybody, for your time. And you all know how to get hold of us, I think, because we've got addresses somewhere in.
Hopefully our emails are in here, so please reach out if you have questions. Absolutely.
And I was just going to add one thing that if you get in conversation with a vendor, I'm sure Scott and I are both very happy to try and be helpful if you need us to.
Yep, agreed.
Okay, thank you, everybody. Take care. Bye-bye.
Thank you, everybody.
Thanks so much, everyone. Have a good evening. Cheers.